Well, hello everybody, class. My name is Sam Fowles. Sorry if I sound a bit groggy and a bit congested. I'm actually fighting a chest infection and pneumonia currently, so it's been a rough few days. But today I'll be doing my presentation, and I'll be presenting my research on water quality monitoring and forecasting for environmental business decisions. This presentation covers my research objectives, methods, results, and insights from my learning experiences whilst completing my project. So the problem I aimed to address was understanding how monitoring and forecasting water quality can help businesses make informed and sustainable operational decisions. Water quality directly impacts business operations by influencing costs, environmental risk, and compliance with environmental standards. The objective of my project was to forecast key water quality indicators such as salinity, dissolved oxygen, pH, and a few others, by analysing their relationships with temperature and other variables to uncover patterns and actionable insights for decision making. So, to address the research question, I utilised a variety of different statistical methods. I used a regression analysis to examine how environmental variables like temperature and salinity related to dissolved oxygen and water depth. I also applied decision tree analysis to explore patterns in water quality changes over time. Additionally, I employed a k-means cluster analysis to identify distinct patterns or environmental regimes based on salinity and temperature data. These methods allow me to uncover relationships and trends in the data. Tools like SPSS and Excel were essential for performing these analyses and visualizing my results. The results highlighted some key insights for me. As you could probably imagine, air temperature was confirmed as the most significant driver of water temperature, with the strongest correlation. However, salinity had minimal predictive power for water depth, which was surprising for me. K-means cluster analysis identified two distinct environmental patterns based on salinity and temperature, which revealed insights into environmental processes. My K-means clustering identified two distinct environmental patterns based on trends in salinity and water temperature, indicating distinct environmental processes affecting these variables. Despite these insights, the hypothesis that salinity would significantly influence water depth was not supported, as minimal predictive power was observed. Additionally, my decision tree analysis did not identify meaningful trends, highlighting some of the challenges encountered during my research. So, as I previously mentioned, some challenges were evident. Several of my original hypotheses did not yield strong findings, and my decision tree analysis did not show any significant patterns. Additionally, there were gaps in data which impacted trend analysis and reduced statistical confidence. Despite these challenges, these findings still provided valuable insights into some environmental patterns. Throughout the project, I developed essential skills like regression analysis and cluster analysis whilst using different types of software models. I faced challenges like weak statistical relationships and data gaps, but these obstacles allow me to strengthen my problem-solving skills and critically assess data patterns using alternative hypotheses and methods. This experience reinforced the importance of statistical models, environmental risk analysis, and forecasting. In conclusion, this research uncovered distinct environmental patterns driven by mainly salinity and water temperature variability. While several statistical relationships were minimal or inconclusive, the findings still provided actionable insights. These insights can help environmental managers, businesses, and policy forecast environmental risks. It can also help better manage resources and allocate strategies effectively. Understanding environmental patterns and key water quality indicators can improve operational sustainability and compliance with environmental standards. Thank you very much for listening, and I hope if you read through my paper that you enjoy my work.